Alright, so this is the second half of our chapter review. We're going to start on number 12. So let me get to the next page. Alright. So we are going to start with number 12. The learning target was I can solve and graph inequalities using the words and or. Solve each inequality or compound inequality and graph the solution on the number line. So with an or statement, we are going to solve the two inequalities separately. So I circle my or statement and I draw my line. So I'm going to start by trying to isolate the variable. So I'm going to subtract 2 from both sides. That gives me 3r is less than 5. R is still being multiplied by 3, so I'm going to divide by 3 and divide by 5. So I get r is less than 1. And I still have my or. So I'm going to write or back down. Then I'm going to solve the right side. So I'm going to add 10, move it over. I'm going to get 7r is greater than 70. I'm going to divide both sides by 7, and I get r is greater than 10. Now I need to write this as one compound inequality. I'm going to do that by placing r in the middle, my smaller number to the left, and my larger number to the right. Now I look at my signs. It says r is less than 1. So the alligator mouth is eating the 1. So down in my compound inequality, it should still be eating the 1. Now looking at the right side, it says r is greater than 10. So what I want is for the alligator mouth to be eating the r. Alright, so we have two inequality signs that are opening to the left. So that would go on your answer line. And now we have to graph it. So I'm going to label 1 and 10 on my graph. 1, 10. Open in circles because there's no equal signs. And r is less than 1. So these are the numbers less than 1. And r is greater than 10. These are the numbers greater than 10. When you have an or statement, the graph goes in opposite directions. Taking a look at number 13, our p is stuck in the middle. So I'm going to start by adding 7 to all three sides. Then you get 3 is less than or equal to 3p, which is less than or equal to 12. 3 is being multiplied by p, so we divide everything by 3. You get 1 is less than or equal to p, which is less than or equal to 4. That is your final inequality. So we're going to write that on our answer line. Now we have to graph it. We have closed circles because there's equal signs. And it says p is greater than or equal to 1, so I shade to the right. And it says p is less than or equal to 4, so I shade to the left. This ends up being an and statement, so we have overlapping graphs. 14. We need to write each interval as an inequality and then graph it on the number line. So things to remember. Parenthesis equals open circle. Bracket is a closed circle. When you graph infinity, you graph and shade the arrow to know you're going off into infinity. So like in number 15. So I like to graph first and then write my inequality. So I'm going to label -4 and 12. I have an open circle at -4, and I have a closed circle at 12. When there is no or in a second interval provided for us, we always shade in between the two numbers. This would be an and statement. So from here, I need to write an inequality. I have -4 on my far left, 12 on my far right, and I'm going to use the variable x. That's my unknown. So I take a look at this first. It says -4 is the smallest it can be. So x values are all greater than -4. So I'm going to put a greater than sign where it is eating the x. Because remember, the shaded part is what x can be. So if we look at 12, all our values have to be less than or equal to 12. So x is less than or equal to 12. Now 15 has our infinity sign. So if we are going off into infinity, we need to shade the arrow. We can't put a dot on infinity. That's why we always shade the arrow to say we're always going in that direction. So I'm going to start with 3. There's a solid dot on 3 because 3 is next to a bracket. I'm going off into positive infinity, so I'm going to shade to the right in my positive direction. From here, when we write an inequality, we do not include the symbol for infinity. We just talk about all the values that x could be, and all those values are greater than 3 or equal to. So I just have my x and a 3, and x's can be any of the values that we shaded. So that's to the right. To the right on the graph is greater than or equal to. So remember, when you have an infinity, you're not writing that in your compound inequality. So now number 16. Now we're working with an inequality, and we want to write it in interval notation. I still graph first because I think it's easier to write an interval notation from a graph. So I'm going to draw my number line. With this number line, I'm going to label 1 and 3 because those are the only two numbers I see. 1 and 3. At 1, I have my open circle. At 3, I have a closed circle. Now I read the inequalities individually. X is less than 1. All the numbers less than 1 are to the left, so I'm shading left. Or x is greater than or equal to 3. So that's all the values to the right. Remember, this is an or statement, so your graph is going in opposite directions, and that's okay. Now looking at the graph, we're going to try to write it in interval notation. So we're coming from this side, which is our negative side. This is negative infinity. We're coming from any number that could be less than 1, and that goes all the way out to the smallest negative numbers we can get. So we're going to start with negative infinity. Oop, that is not the infinity symbol. Negative infinity. And then our next number that we run into is a 1. 1. And I'm going to put a parenthesis because it's an open circle. Then I have my or. I have a bracket because there's a closed circle now. And that's on a 3. Now, I'm shading off to the right. Any number that could possibly be bigger than 3, so that goes off into my positive infinity direction. So that would be interval notation, and graphing. On 17, we're going to graph it first. So draw your number line and label a 4. Now, it can't be equal to 4, so we have an open circle. And x is anything less than 4. So we're going to shade to the left. Less than, left. Any number less than 4 can mean any negative number. The smallest negative number you can think of. Negative 1 million, negative 1 billion. It goes on and on. So we're going to label that as negative infinity to convert this to interval notation. So we're going from negative infinity, then we meet at this 4 with an open circle, so that means we have a parenthesis. And that is our interval notation for this inequality. All right, 18 through 21 is solving absolute value equations and inequalities. So remember, we want to isolate the absolute value symbols first. In number 18, our absolute value symbols are already isolated, which is great. So we can get right into this. To get rid of the absolute value symbols, we take the opposite of our number 3, which is negative 3, and write negative 3 equals. We take everything that's inside the absolute value symbols and rewrite it, r minus 9 equals, again, we have positive 3. Remember, absolute value, you can put in a positive number or a negative number, and you always get a positive number out. So now we're going to solve this. So what you do to one side, you have to do the other 2 sides as well. So we're going to add 9 to start to isolate the r. So we get 6 equals r equals 12. We're done. We have 2 exact answers for this because it's an equation, because it has an equal sign. So r can equal 6 and 12. Not positive or negative 6, not positive or negative 12, just 6 and 12. Number 19. Remember, our goal is to isolate the absolute value symbols. The absolute value of d plus 2 is all being multiplied by 5. So to get rid of that, I'm going to divide by 5 on both sides. Now that I've isolated the absolute values, I can start to get rid of the absolute value symbols. I'm going to take the opposite of 4 and set it equal on the other side. Now I lose my absolute value symbols to get an equation that I know how to solve. I need to get 2 away from d, so d is alone. So d has 2 answers. D could equal negative 6, or d can equal 2. Okay, our last 2 problems are inequalities. On both of these problems, the absolute value symbols are already isolated. So that just means we need to get rid of the absolute value symbols. So we take the opposite of the number on the far right and place that on the far left. So the opposite of 11 is negative 11. I take the exact sign here and place it here as well. Now I can drop the absolute value symbols and just write what was inside. Now I have my positive and my negative values of 11. Now I start to isolate C. I'm going to start by adding 1. Sorry, it looks like I'm dividing. I'm going to erase that. adding 1 to all three sides. So I get 10, negative 10 is greater than 4c, which is greater than 12. I'm going to divide everything by 4. And I get negative 2.5 is greater than c, which is greater than 3. And I am done. Because this is an inequality, you have a range of answers. You have no equal signs here. So you have a range of answers. C could be anything from negative 2.5 all the way to positive 3. Let me correct that. C can be anything less than negative 2.5 and anything greater than 3. This will be an or statement, so the graph would go in opposite directions. It is not an and statement. So we have to do the same thing on number 21. Take the opposite of 6 and place it on the far left side. Use the same exact symbol in the same direction that it is in the inequality. We get to drop the absolute value symbols. Now we solve. To get y alone, we have to add 3 to every single side. And you're done. So negative 3 is less than or equal to y, which is less than or equal to 9. So you have an and statement here. And that is how you finish up the second page of the chapter review.